Now that we've practiced our stoichiometry calculations, we can apply this to a larger problem called a limiting reactant or a limiting reagent problem. If you consider most chemical reactions, so here's a generic one, A2 plus 2B gives me 2AB, it's nearly impossible to combine the exact amount of reactants so you use them both up and have nothing left over. Instead, it's much more likely that you're going to add a little more of one than the other, so one reactant is going to run out first. We call that reactant the limiting reactant. The other reactant that you have too much of, we call the excess. So in a limiting reactant problem, we're typically given the amounts of two reactants and asked to say which one is the limiting reactant. And we can do this in a few easy steps. For each reactant, you're going to calculate how much product it could make. Whichever one makes less product, that's your limiting reactant. If you have a reaction with more than one product, it doesn't matter which one you choose, as long as you use the same product for your calculations. So we're basically just going to do a stoichiometry problem, but we're going to do it twice. When we do these limiting reactant problems, it also gives us some extra information. In calculating the limiting reactant, we also calculate what's called the theoretical yield. This is the amount of product we should get if we use up all of the limiting reactant. So we're going to see this come straight out of the problems that we're doing. When we're actually in the lab, we don't always get that much. A lot of things happen, things don't go as well as we'd hope, so a lot of times we get less than we predict. So what we actually get in the lab is my actual yield. So that's what I got at the end of my experiment. And I can see how close I was to my theoretical by getting a percent yield, which is just actual over theoretical, times 100%. The closer I am to 100%, the better I did in the lab. So let's look at an example of one of these problems. Consider the following reaction. When 5 grams of HCl is reacted with 3 grams of barium hydroxide, 3.15 grams of barium chloride are collected. Determine the limiting reactant, theoretical yield of barium chloride, and percent yield. So notice it doesn't mention water at all, so we're probably just going to ignore him for this entire reaction. Meanwhile, I like to go in and write in the information just to organize it. So I see that I have 5 grams of HCl. I have 3 grams of barium hydroxide, and at the end I collected 3.15 grams of my barium chloride. If it gives me an amount of product at the very beginning, this is my actual yield. That's what I actually got in the experiment. And I'm not going to do anything with it until at the end when I want to calculate the percent yield. So for right now, I'm just going to put him in my back pocket. First, to figure out the limiting reactant, I need to take each reactant and do a little stoichiometry problem. Figure out how much product I could make with each one. So let's start with HCl. If I start with 5 grams of HCl, if I want to figure out how much barium chloride I could make, I know I'm going to have to go to moles, and then I'll do the mole-to-mole ratio, and then I can go back to grams. So first things first, I want to get rid of grams and turn those into moles of HCl. So we calculate the molar mass from the periodic table. For every 1 mole, it is 36.461 grams. So now my grams are going to cancel. Now I'm going to get rid of my moles of HCl and turn those into moles of my product, barium chloride. So we look at my balanced equation. Next to HCl, there's a 2. Next to barium chloride, there isn't a coefficient, which implies a 1. So now my moles of HCl have canceled. Now I want to go all the way and turn this into grams of barium chloride. If I was just worried about the limiting reactant, I could stop here, but since it asked for the theoretical yield in grams, I may as well go ahead and calculate the grams. So for every 1 mole, if I get the molar mass of barium chloride, which is 208.236 grams, I can figure out how many grams of barium chloride I'll make. So now my moles have canceled. So we go gram, mole, mole, gram. If we do the math, we get 14.28 grams of barium chloride. And if we look back, we had 2 sig figs to begin with. So I can just, that should be under my 4, underline my 4 to keep that in mind. Okay, so I've done my first calculation. Now I'm just going to do the same thing, but I'm going to start with my barium hydroxide. So this time I will start with 3 grams of my barium hydroxide. Once again, I want to go to moles. Got to get rid of my grams. So I'll calculate the molar mass of my barium hydroxide, and that is 171.34 grams. So I can get my grams to cancel. I still want to get rid of my moles of barium hydroxide and turn it into moles of barium chloride. So I need to end up in the exact same product as I did before. If we look up here, neither of these have a coefficient, which means each of them has a 1 implied in front of it. So now I've gotten rid of my moles of barium hydroxide. Last thing, I want to get rid of my moles of barium chloride. And, oops, what am I doing? And turn it into grams of barium chloride. Same exact molar masses up there, so every 1 mole is going to be 208.236 grams. So we'll just squeeze him in there. All right, and now my moles are going to cancel, so once again I will end up in grams. Let's just scroll down a bit. So if I do the math, I get 3.646 grams of barium chloride if I start with 3 grams of barium hydroxide, 2 sig figs. So I've just done the same calculation twice, stoichiometry starting with both reactants, and now I just need to compare the products. I had 14.28 here, I have 3.646 here. The smaller number, this is what's going to tell me my limiting reactant. So this is a product. It can't be a limiting reactant, but I'm going to go back to what I started with, my barium hydroxide. This is my limiting reactant. My limiting reactant is the thing that made less product, and the amount of product it makes, that's my theoretical yield. So we can see they're linked. They're not the same thing. The limiting reactant is what I started with. The theoretical yield is what I end with, and I judge it just by which thing made less product. So the first 2 questions are answered. I know my limiting reactant. I know my theoretical yield. The last thing it asked for was the percent yield, and if we recall, it gave me an actual yield of 3.15 grams. It didn't say actual yield, but it told me how much product I made, so I know that's what it meant. So my actual yield is 3.15 grams of barium chloride, and good news, my percent yield is super easy. Actual yield over theoretical yield times 100%. Actual yield is 3.15 grams. Theoretical is 3.6 grams. My grams will cancel, and I'll turn that into a percentage, and I find that I got an 86% yield. Not too bad, all things considered. So keep in mind, limiting reactant problems, you just take each reactant, turn it into product, whichever one makes less. That's your theoretical yield. Whatever reactant that came from, that's your limiting reactant. And if it gives you an actual yield, you can then use that to get your percent.